Hi, welcome to this question on calculus optimization problems. Let's have a look at question 4. A horse ranch is constructed around a barn as shown in the diagram. The fencing for the ranch is given by A, B, C, D, E, and we are only restricted to 100 meters of fencing cable to create this fencing around the ranch A, B, C, D, E. Okay, if we are given that AB must equal DE must equal X units, and BC equals CD must equal Y units, then we want to find the dimensions of X and Y that will produce a maximum area for this horse ranch. Okay, so first of all, if we have a look at this diagram here, AB, BC, CD, and DE, those are the four pieces together that make up this fencing. Okay, so there's this little block that's essentially cut off here that would sort of make it a square, right? So we were given that AB equals X, just like DE over here. And then we're given that BC equals Y and CD is also equal to Y. So how can we find the area of this ranch in general? Well, it almost looks like a square, not a square, but a rectangle of X by Y, okay? So I would say that the area of the ranch in terms of X and Y is this full ranch area, X by Y, so X times Y, but minus this piece here. What's the dimensions of that piece? It looks like a square. Well, if the total distance from B to there is Y, which is given by CD, and this distance BA is X, then the larger distance Y minus the smaller distance X would give us the dimension of this part here, Y minus X. And then similarly here, this larger distance is Y, but then we're subtracting off the smaller distance X piece. So this dimension here is also Y minus X. So there's a little square piece here that has dimensions Y minus X. So the area of that square piece is Y minus X squared, because the area of a square is its side length squared. So now I have an expression for the area of the ranch, right, given the dimensions X and Y for the fencing, in terms of those dimensions X and Y. Okay, but we want to produce a maximum area, so we want to maximize this function. That's what we want to do. Okay, well, first of all, it's of two variables. So if I can make it in terms of just one variable, then I'm fine, right? So either X or Y. What other information will be given that can help us? Well, they told us that the fencing is restricted to 100 meters. So what does that mean? Well, let's look at this. The fencing is made up of what? So the fencing is made up of these two pieces of X plus these two pieces of Y. And that must be 100 meters in total. So if I divide both sides by 2, I get X plus Y equals 50. All right, and then if I isolate Y, I can write that as 50 minus X. Now that is Y in terms of X. So if we substitute that into here, then we can have just a function of X alone. So let's do that. Let's substitute that into the area formula. So we'll have area of just X equals X times Y, which is 50 minus X, minus. Now inside this brackets, I have Y is 50 minus X minus X, all squared. So that's going to give you, if I expand that out, 50X minus X squared minus, and inside this brackets, it's 50 minus 2X, all squared, because negative X minus X is negative 2X. Okay, let's expand that out. So 50X minus X squared minus. So let's expand out the brackets. 50 squared, that's going to be 2,500. The product is going to be negative 100X. Double it, so negative 200X. And then squaring negative 2X, that gives you positive 4X squared. Okay, so if I expand out that negative sign now, I have 50X minus X squared minus 2,500 plus 200X minus 4X squared. Okay, so make sure you distribute that negative sign out correctly. Okay, let's clean up like terms. Negative X squared, negative 4X squared, that's negative 5X squared. 50X plus 200X, that's plus 250X, and then minus 2,500. So that is the function of the area of the horse ranch with respect to one variable X. So how do we find the maximum area? Well, we need to find the first derivative, a prime of X. So if I find the first derivative here, that's going to give you negative 10x plus 250. That equals 0. So solving for x, I have 10x equals 250. Bring over the negative 10x. Therefore, dividing both sides by 10, I get x equals 25 meters. Don't forget to put your measurement. Okay, so that was x. And we can find y because we've already got an expression for y in terms of x. So y is 50 minus x. So 50 minus 25, that's 25. So x and y must be both equal in length, 25 meters. And if you look at that, you'll have 25 meters plus 25 plus 25 plus 25. That gives you the 100 meters of fencing cable that we were restricted to. And on top of that, it'll give us the maximum area. So the dimensions that will produce maximum area is when x and y are both 25 meters. And to find that maximum area, if we wanted that, we can substitute it back into this original expression. So that's going to give you 25 times 25 minus, well, 25 minus 25 is 0 here, squared. All right, so 25 times 25, that's going to give you 625 square meters. Okay, so that'll be the maximum. So this area of this blue ranch here, okay, that's excluding that red square there, that is 625 square meters, okay, based on the formula for that area of the ranch. All right, so that's how we would solve this type of question. I'll see you in the next one.